In this video, we're going to look at projectiles with horizontal and vertical vectors. So let's take an example. So a ball is struck by a racket at a point A, which is 2 meters above horizontal ground. Immediately after being struck, the ball has a velocity of 5i plus 8j meters per second, where I and j are unit vectors horizontally and vertically respectively. After being struck, the ball travels freely under gravity until it strikes the ground at the point B, as shown in the diagram above. Find the greatest height above the ground reached by the ball, the speed of the ball as it reaches point B, and the angle of the velocity it makes with the ground as the ball reaches B. So the first thing we ought to do is to draw what the diagram for this question looks like. So I will draw that out here. So we have a vertical line here. We have a horizontal line like so. And we have the velocity going like this. And then we're going to draw our projectile motion. Like so. Now, they tell us that this is 2 meters. We have a vector 5i plus 8j meters per second for its corresponding velocity. This is the point A, this is the point B. Now, part A of the question says to work out the greatest height above the ground reached by the particle. So what we're going to do now is take upwards as positive. So upwards as positive here. And we're going to do a suvat, as what we always do in projectiles. So we're going to have that A is minus G. Now, in the vertical sense, we're going to use the J component. So the initial velocity is going to be 8. And at greatest height or maximum height, the velocity is 0. And we want to find S. So the suvat equation we're going to use is V squared is U squared plus 2AS. So we can say that 0 squared is 0, is 64, which is 8 squared, minus 2GS. So 2GS is equal to 64. So S is 64 over 2G. Let's get our calculator. So we can type that in here. 64 over 19.6. And that's going to give me 3.27. But the question's asking for the greatest height. So we need to add on the 2 meters. So then we'll get so the greatest height reached will be 2 plus 3.27, which is 5.27 meters, correct to 3 significant figures. Now for part B, the question says to find the speed of the ball as it reaches B. Now we need to find its horizontal components and its vertical components. Now horizontally, the velocity doesn't change. It will remain at 5, but we need to find the vertical components. So if we find the vertical component of the velocity, so what we're going to do here is we're going to take upwards as positive again. So we're going to do it as suvat. So A is minus G. Now don't forget that in the upward sense it will be the J component, which is 8. Now we were trying to find the velocity, and we also know that the displacement would be minus 2 below the point of projection. So S is minus 2. So don't forget it's minus 2 because it's 2 meters below the point of projection there. So we're going to say that V squared is U squared plus 2AS. So V would be the square root of 8 squared is 64 minus 2G times the value of S, which is minus 2. So V is the square root of 64 plus 4G. So we can write that as the following. We could write 64 plus 4 times 9.8, which is going to be 103.2 square rooted. But don't forget, we call this V of Y because that's in the vertical sense. Now V of X is a constant velocity of 5 because it's 5I. So now we can find the speed by using Pythagoras. So that's going to be 5 squared. Now root 103.2 squared is simply 103.2, and we're going to round our answer to 3 significant figures. And that will give me 11.3 meters per second. Then part C says to calculate the angle the velocity of the ball makes with the ground as the ball reaches B. So let's do that then. So we can say, well, we know that the following, so we've got the Y components to be, or the vertical components to be 103.2, and we've got the horizontal to be 5, so we can draw that here. So 5, and then we got square root 103.2. And what we want is, we want to calculate this angle, theta. So we can say that theta would be arctan. It's the same thing as tan inverse. Square root 103.2 over 5. And we're going to round that to 1 decimal place. So arctan square root 103.2 over 5. And that's going to give me 63.8 degrees to 1 decimal place here. So we get that. Here's a question for you to try. You can pause the video, and when you're done, I will go through my work solution. Okay, welcome back. So an object is projected from a fixed origin O with a velocity of 4I plus 5J. The particle moves freely under gravity and passes through the point P with position vector K times I minus J meters, where K is a positive constant. Find the value of K. Find the speed of the object at the instant when it passes through P, the direction of motion of the object at the instant when it passes through P. So what we're going to do here is, first of all, we ought to underline our vectors. So we'll do that here. So now we're going to draw a diagram. So we know that our particle has a velocity of 4i plus 5j respectively meters per second. So there we can draw our projectile motion, draw in our horizontal displacements. So we can draw it like this, and this is our origin. So now what we can do is to take the horizontal component. Now notice that the position vector horizontally would be ki, as in the I direction, so the value of that would be k, and it's positive. So when we do a suvat here, we can do a suvat here. Now horizontally it's constant velocity, so acceleration is 0. We know that u is 4, because that's the component of I here, and we know that s is k. Now what we need to know is the time of flight, so we can say that horizontally that s is ut. Now k is going to be 4t, so therefore we can say t is k over 4. So now that we know our time of flight, we can now take the vertical sense. So we can now do a suvat vertically. So we're going to do a suvat here. So a is going to be minus g. Then we can say the time of flight we just worked out is k over 4. Now we notice that in the position vector here it will be minus k. So it will be minus k here. And we know that for the initial velocity it's going to be 5, because that's the component of j. So we can write 5 here. So the suvat equation that we're going to use is s equals ut plus a half at squared. And that's going to be minus k. So we can say 5k over 4 minus 4.9 k squared over 16. And then we can solve our, so we can get times by 16 here. So we can get the following here, minus 16k equals 20k minus 4.9k squared, and then we can get 4.9k squared minus 36k equals 0. So we get k times 4.9k minus 36 equals 0. And k equals 0, or k equals 36 over 4.9. So we can say that k is 7.35. Now, the next part of the question states, find the speed of the object at the instant it passes through P. So again, like the previous example we did, we're going to have to find the vertical and the horizontal components of the velocity. Now, horizontally, it remains fixed. We just need to find the vertical components. So we're going to do a suvat again, taking upwards as positive. So we can do suvat here. So that's going to give me S is minus K, U is 5. We need to find the velocity, and A is minus G. So now we can say that V squared is U squared plus 2AS. Now I'm just going to make it very clear and write Vy. That's the square root of the following. So we get 5 squared minus 2G times minus K. And then what we're going to get, well, we know what K is. It's going to be 7.35. So it's 25 plus 2G times 7.35. And that will give me 13. Now we know that Vx was, go back to our question, Vx was 4, so we can write that in. So Vx is constant, that remains as 4, therefore the speed, we can use Pythagoras here. So that's 4 squared plus 13 squared, and that's going to give me 13.6 meters per second. Then part 2 says find the direction of motion of the object at the instant when it passes through P. So this is exactly like the same as the previous example. So we know what Vy was. So we know that Vy was 13 and Vx was 4. So we've got 4 going this way, and we've got Vy forms a right angle triangle here. So let's draw our right angle properly. That's 13. And we're interested in this angle here. So that's theta. So we can say therefore theta is arctan opposite over the adjacent side. So it's 13 over 4. And we're going to round that to 1 decimal place, so we get 72.9 degrees, and that's being rounded to 1 decimal place.